All right, guys, as I was saying about the histogram, we note that the horizontal axis will either represent the class boundaries along that axis, or we can represent the class midpoints along that axis, or in some cases, we can use the class values for the limits and so on along that axis. But for the frequency, is generally the vertical axis that we use for the frequency, except in the case where we are using the area of the bar for the frequencies. All right. Now, in our situation, for most of our histogram that we'll be doing, we'll be using the boundary values. Reason why we're using the boundary values, because it works well when we are looking at the cumulative frequency curve, which you would use to calculate median, mean, which you use to calculate the mean and the quartiles of the, sorry, I said mean. It would be the median when we are looking at the cumulative frequency curve to calculate the median value, right? So the boundary values will give us a nicer curve when we use it to plot that O-guide or O-give that, you know, some books have it. Some people call it in different ways, all right? So here we have a histogram is a frequency diagram with unequal class intervals, all right? So as I was saying, the class intervals don't necessarily have to be equal, but when the class intervals are different, you may choose to use the area in the diagram. Now, here they're saying that the histogram is a frequency diagram with unequal class intervals. The area of the bar represents the frequency. All right, so when we said it's unequal class interval, it means that the width of the bars are not the same. In this case, we're using the area of the bars to represent the frequency. So I hope you guys have that clear. Why have a different class interval? Sometimes data will be collected where there may be very little data in one class, and yet in another class, the interval of the same width, you will find that it is better when for some cases, because if you, let's say you create a group distribution table, and you would expect that one group would have a lot of data in it, but you realize that there is not enough data within that class, then sometimes it might be better to have the classes which would be more connected to give a bigger class. So you, instead of having a small class interval, you make a bigger class interval so that you can collect more data within that bigger class interval, all right? So that's all it is saying. But as I said, most of the questions we'll be looking at, I don't think we'll have to be relying on the area, but just to know that the area can also be used to represent the frequency. Go ahead, Mr. Campbell.
Sir, did he keep the marathon already, sir?
If I did one?
Keep the marathon. I swear I saw something about the marathon. So I was wondering if that happened already.
Well, if you're just seeing that, that means you're late. That was postponed in the interest of the few response that we get. It wasn't worthwhile for me to make the effort to do that. All right. So that would have sent out from some time, but apparently some persons are too busy doing other things for their holidays. All right. All right. So looking at this, frequency distribution table, which is a group distribution, you can see all the various classes in the left column for ages. On the right, you see the frequency. Now, when you look at this table, the frequency is telling you how many data or how much values fall within a particular class. So for the class of 0 to 15, you have 4 values that fall within that range, right? And the values that fall within that range can be from 0 to 15. So you could have 1 falling in that range, 2, 3, 4 values up to 15. But you find only 4 values that they have in that range. So the frequency for that class would be 4. Likewise, for the second class, only 14 values fall within between 15 or from 15 to 20. And so on with all the other classes. All right, so a survey was conducted to find the ages of 60 surfers. The results are in the table below. All right, notice that the class intervals are different. Now, if you look at these class intervals, what intervals would be different in terms of their sizes? First one go from 0 to 15. You could basically check the class width to see if all the class widths are the same. And if they're not the same, then you know that they have a different class width, which is the interval would be different. All right, so between 30 and 40, you would have 10. The difference would be 10. Between 25 and 30, the difference would be 5. 20 and 25, the difference is 5. 15 and 20, the difference is 5. 0 and 15, however, the difference would be 15. From 40 to 70, that would be a difference of 30. So you see, you have these classes, 40 to 70 and 0 to 15, those have different class intervals in terms of their difference. All right. Now, if you kept the class interval of 5 as ages 15 to 30, you may find that several empty classes between 40 and 70 would occur, right? And you notice why that would happen? Because between 40 and 70 is only 10 values they find within that interval. So because you have fewer data between 40 and 70, they don't bother to keep the interval, because if you're doing the interval every 5, like from 25 to 30, from 30, you go from 30 to 35, because you want to keep that interval going. And then now you go from 35 to 40 and so on. But if you do that, you will find, based on this frequency down here, you will find that you would have less persons within these intervals from 40 to 70. So they just merge this class into a big class to just deal with just that 10 persons. All right, that's what all that is saying. So if you kept the class interval of 5, you may find several empty class intervals between 40 and 70 because the class width is different. If we use frequency for the x-axis, the size of the bar, would represent frequency disproportionately. All right, so all they are saying that the adjustment in the class for our frequency is dependent on how many data you would find for each class. All right. So they will conveniently adjust it in some cases where you don't have, when you have a disproportionate proportionate frequency distribution, you can merge some classes to get some more data between them. All right. All right. So we use frequency density to show the height. The frequency density is the area of the bar, and the width of the bar is the class width. All right. So I hope you are paying attention to what is being said here. The frequency, we use frequency density to show the height, which is generally what we would put as the frequency, but instead of putting the frequency on the vertical axis, we're going to put what on it? Frequency density. But what is frequency density? Frequency density is simply the area of the bar. Right? So if you're drawing a histogram where you're representing the bar in terms of the area, the vertical axis, you won't write frequency. What you instead write is frequency density. Is that clear, guys? All right, apparently it's not very clear, but let me see if I can cement that. We know that our bars, when we have an ordinary frequency distribution, we have our vertical axis, which is generally represented by the frequency. And we have our x-axis, which is generally represented either by the class boundaries or the class. And in this case, the height of the bar would tell you the frequency. Now, if we are not using the height, because if we are using the height of the bar, that means all the bar would have the same width. Right? But in some cases, when we are actually using more than one class together, when we are merging classes, we don't bother to use the height now to tell the frequency. So we use the area of the bar. Now, if we are using a bar that we are going to calculate the area to get the frequency, then the vertical axis now, we are going to write not frequency, but frequency density. Because when you're finding the area, you're measuring the frequency density. That's all we're saying, guys. Is that clear? Raise your hand. All right, let us go through and see what it is saying. So the frequency density, which is the area of the rectangle, can be also, it can be denoted by the frequency divided by the class width. So to get the frequency density, you divide the frequency by the class width. Now, so if you multiply the frequency density by the class width, you will get the frequency. You follow what I'm saying? So if you multiply the class width, because this is a class width, you know. So the class width is actually the width of the bar. And the height of the bar is the frequency density. The area of the bar would be the length times width. the height is the longer side, so you have to call this the length, and you call this the class width, the width. Then the area would be the class width times the frequency. Is that clear? Sorry, times the frequency density. So if you take this and multiply the frequency density, that's how you get the actual frequency from it. That's why we said the area of the bar give you the frequency. Is that clear? So in this case, our vertical axis, we're going to label it as frequency density and not frequency. Because in order to get the frequency, you actually have to multiply the frequency density by the class width, which gives you the area of the rectangle. All right, moving along. All right, look at this now. All right, let us go back here just to remind you of how we get the frequency density. How we get the frequency density, guys? Divide the frequency by the class width. Is that clear, Ms. Faisal?
Yes, sir.
Mr. Paisley, Mr. Shamar, Mr. Shamar?
Yes, sir. Yes, sir.
Clear? All right, so it means that if we're going to construct this histogram based on this, and we're now going to use the frequency, the class width, and the frequency density. Anybody remember how to calculate class width? Ms. Raysom, remind us how to calculate the class width, please.
Frequency divided by frequency density. Like that.
All right.
Not sure.
We're not talking about from here. We're talking about from when we're looking at the
Oh, yes, sir. So the class width would be for the lower boundary minus the upper boundary, sir. Or the upper boundary minus the lower boundary.
The other way around. It's always the
upper boundary minus lower boundary.
Right. So it means then you would have to calculate the class width of each of these. Right? And if you go ahead and calculate the class width, you should get the class width based on these. All right, so you can check it for verification. Let us check the first one. How would you find the class width for the first class? If you have a class before this class, well, there's no class before this class because it started from 0. So the width of this class would be from here to 15, right? Remember also, if we subtract boundary values and based on all these, can you notice that these classes are labeled different from how we would have had them when we have when we're using the regular height, because if this is 15, the next one would be what, 16 and so on. But these are labeled differently. So the width of the class would be just the value between the lower limit and the upper limit. So this class starts from 0 and it ends at 15. So it has a class width of 15. This value starts at 15, ends at 20. So for these, to find the width of the class, you simply find the difference between the two limits. So you take away 0 from 15 and get 15. Take away 15 from 20, you get 5. Take away 20 from 25, you get 5. 25 from 30, you get 5. 30 from 40, you get 10. and 40 from 70, you get 30. So those are the class width based on this class. Is that clear, guys? Raise your hand if it is clear. All right, so we know from this, if we have these kind of values, we could simplify the class width using that means. Now, remember now the frequency density. How do we get the frequency density again?
Frequency divided by class width, sir. Or class width.
So the frequency divided by the frequency divided by the class what? The class width. All right. So if you divide each frequency by the class width now, do the calculation and tell me what you get. 5 divided by 15.
Sir, go again, sir.
You're dividing the frequencies by the
Yes, sir.
class width. Right. Frequency density would be what?
3, sir, for the first one.
Would be 3. So 1/3.
Oh, 1/3, sir. 1/3, sir.
Right. The other one would be what?
3, sir.
The other one would be?
2.
The other one would be?
8/5.
And the other one?
Okay. Okay.
All right. So it means that the frequency density is the height of the bar with the class width that we are going to be using, right? So each of these bars going to have their own class width. So if you look at each of these bars, their class width would be different, right? The first bar have a width of what? 15. You see it? Where was it at? I use a different color. So the first bar has a width of 15 because you're going from 0 to 15. So this is the width of the first class. The other class from 15 to 20 has a width of 5. So from 15 to 20, the width would be 5. The other class has a width of 5 again, from 20 to 25, 5. And then now from 25 to 30, going to give you 5 again. So these 3 width would be these 3 middle bars here. Now the width of this bar from 30 to 40 would be 10. And this last bar here, from 40 to 70, the width would be 30. So you notice that all of these bars have different width. All right. Now their height is based on the frequency density. Notice that this is 1. And if you divide it into 3 equal parts, each part would be 1/3. So it means that this is 1/3 of the 1. And then now.
Sir, could you mark that back so I can see, please? Where is the 1/3 would fall, sir?
Just a rough estimate. It would be about there.
Okay.
All right. So that's roughly 1/3. This is roughly 1/3 of 1. Then the other part now would measure 3. So for this bar, you will go all the way up to 3. For the next bar, you would go up to 2. And for the other one, you will go up to 1.6. So this is about 1.5 here, 1.6 would be right here. And 1.1, 1.2 would be 1 and 2 tiny boxes, both right here. And then the other one now would also be 1/3, which is around here. All right, so this is how you would construct this histogram. If you want, so you label this axis as frequency density. If it is that now you want to find the frequency, then you would have to go through and find the area of each of these boxes, multiply the length times the width. So the height of this would be 1/3. So if you want to find the area, it would be 1/3 times the length, and the length is 15. And remember, the length being 15 would be the class width. So 1/3 times the frequency density times the class width actually give you the frequency, which is actually the area of the bar. Class width times frequency give you what? Frequency. So just multiply these if you want to find the frequency. So you don't use the value of the height to give you the frequency for these. You use the area of the bar. All right, I hope everybody is following so far and understand clearly. All right, so from this histogram, you could be asked a further question. So you could ask the question to estimate how many people between the ages of 35 and 45. All right. Now, so you would have to identify the area of the bar to which this applies. So we're looking from what? 35 to 45. You go to the bar, you look for 35. Where's 35? 35 is about here. Somewhere in the middle. All right, and you're going to 55. So 55 is about here. So what you need to do in order to find, you want to find how many people within this region and this region. It means that you now would have to isolate these regions. So you would have that one rectangle there. And then now you find the area of that rectangle. You have this rectangle here. And then you would have to find the area of both rectangles that I'm highlighting. The area of both rectangles and add them together, right? So from 40 to here, how much that would, what length would that be? So from 40 to 55, what is the length we would have there, the ages that we would have there? So you would...
What's the difference there, sir, between what?
Between 40 and 55 could be the length of that bar. You take away 40 from 55, how much you have left?
15, sir.
15. So this bar would have a length of 15. And the height of it would be what? 1/3. Right? And then we would have to find the width of this bar from 35 to 40, the width of this would be what? 5. And the height of this bar would be, it would be
1.2, I think, sir. You got.
So we are finding the area of each of these bars and then add them up. So you would multiply this 5 times 1.2 for this bar. Then you have 15 times 1/3. You find those two areas, you add them and you get what they're asking you for. You have to estimate how many people between the ages of 35 and 55. All right? So that's how you would do that. So you get those bars. Remember that the frequency is the area. Find the area separately of each bar. So you multiply area times frequency for each bar. Oops. And then now, for the area of one bar is 6, the area of the other one is 5. You add the two of them, and then now you get 11. So the estimated frequency of the number of persons from ages 35 to 55 would be 11 persons. All right, I hope you get that. Let me see the hands of those who understand what is happening. All right, I'm not going to dwell on this too much because this is not it's not a popular kind of questions to come on exam, but it's good for you to understand what is happening. All right, so we are looking now at statistical averages, which are often referred to as central tendencies. And why they are referred to as central tendencies? Because in terms of the data, if you have a range of data, let's say from 1 to 20, you have numbers from 1 to 20. The center between the two numbers, 1 and 20, would be somewhere where would be about 10. Everybody agree with that?
Yes, sir.
So the middle, if you add the first number, which is 1 and 20, and divide it by 2, you get the middle of the data, right? So that's why we call it the average. The average is closer to the middle of the data. And it is also called the central tendency, because central means center, and tendency means that you have a tendency to be towards the center. So when we talk about averages, we are talking about values of data that have a tendency to be the middle value of the data. And that's why when we look at the mean is actually the middle value. When we do the median, it's also the middle value, but they are calculated differently. Whereas the median, you just pick out the middle value. The mean, you add up all the values and divide it by the amount of values. And the mean would actually give you somewhere in the middle. The mode, the most frequently occurred values, generally they would also fall within the middle. So for statistical averages, we commonly use these because each of them have their own advantages and disadvantages. And these are what we may want to find. We will choose the one that best suits that particular data that we're trying to find. All right. So we say raw data does not mean much until it is arranged into a frequency distribution, or represented by a histogram. To make data more meaningful, it is to try and find a single value which will represent all the values in the distribution. So a single value. And the single value now tend to be the middle value. So the single value which will represent all the values in the distribution is called the average. Several kinds of averages are used in statistics. The more important ones are the mean or arithmetic mean, the median, and the mode. All right, guys, so these are central tendencies or averages, and we will be learning how to calculate these in the next sessions, all right? So at this point, I'm going to stop as we would have been at the end of the session. All right, guys?